All right, everybody says Algebra 2. This is spring test number 6 study guide. It's for week 6. We got addition and subtraction and start. Anytime you add and subtracting fractions, the key and the most pain in the butt part about it is the bottom number has to be the same. The denominator has to be the same. We got to very briefly different denominators the other day, and we never quite got a chance to cover them. So none of this test will cover anything with changing denominators, luckily. So this ought to be a really easy section. You just combine them and then you reduce them. Number 1 says negative 12x at the bottom of both of them. So you want to keep that the same, negative 12x. Then you want to add what's going on top. If it didn't have anything at the bottom, if all you had was negative 6 plus negative x, which means minus x, minus 6. So we can take out that plus in the middle. Then you just combine your like terms. Negative x and negative x is negative 2x. And then 6 and negative 6 would be plus 0. So we got rid of that. So what we have is negative 2x over negative 12x. Then you just have to reduce or cancel out what they have in common. They both got an x in common, so we can get rid of that part. And the number negative 2 goes into both of them. It goes into 2 one time, and it goes into 12 6 times. So there's your simplified version, 1 over 6. Number 2 is very similar. You have the same number at the bottom again, or the same expression, x minus 9 at the bottom, so leave it like that. If you didn't have anything at the bottom, if all you had, if all you had was negative 5x minus a negative 8, you didn't have anything at the bottom, that would be negative 5x plus 8. We cannot put these two numbers together for the same reason we never can put them together, because they're not like terms. So what we have is negative 5x minus a negative means plus 8. Then at this point, you just have to see, is there anything I can simplify? Is there anything I can reduce? Is there anything I can take away? And no, there is nothing you can do, because there's an x at the top and the bottom, but it doesn't multiply by the 8 and it doesn't multiply by the negative 9. So that's all you can do with it. Plus minus the negatives means plus is the only thing you could do for that one. This one does, you could do a little bit more with this one. Let's leave the bottom alone at the beginning. You can reduce it right away or factor it out right away, but we'll leave it. You don't have to write it in a fraction, parentheses. We'll just leave it like that just for right now. We'll come back to it in a second. Combine what's on top. We subtracted them in this case. So 6x minus 7x is going to be negative 1x. So negative x. And then negative 1 minus a negative 6. Don't lose the fact that says minus a negative. It means plus 6. So negative 1 plus 6 is going to be plus 5. Now what you want to do is you want to separate that bottom or factor it out. So at the bottom of that fraction, this is the difference of two perfect squares. Remember, with the difference of two perfect squares, it means x plus 5 times x minus 5. Anytime it's talking about the difference, you got to subtract 1 plus and 1 minus. So you have x plus 5 and x minus 5. And at the top, we have negative x plus 5. Now, here's one. I don't think we've seen any like this. In fact, I think we had one that was really similar, and we kind of went past the one last step we can do on it. If you look at the signs for each of these, negative, it says negative x and it says positive 5. None of the ones at the bottom say negative x. What we can do, though, is we can multiply this top expression by something to change the sign. In order to change the sign, all you do is multiply it by negative 1. So when you multiply it by negative 1, it gives you x minus 5. But if we do that, it's going to mess the problem up. The only way we can justify doing that is if we multiply everything at the bottom by negative 1 as well. Because what that's doing, if you look at it as two separate problems, all of this are two separate things instead of the way I wrote them. Let me write them separate the way you'll see what I mean. If I multiply it as negative 1 over negative 1, any number over itself like this is like multiplying something by 1. It's just like rationalizing out a denominator when you have 2 over the square root of 2. You can get rid of that square root at the bottom by doing this, because all of this is 1. And when you multiply something by 1, it doesn't change what it is. So when I multiply this whole fraction by negative 1 over -1, it doesn't change what it is. It just changes the sign to where we can cancel one more thing out. So again, when I switch that, -1 times -1 is going to cancel my signs and make it say x minus 5 on top. And then -1 times x is going to be -x. And -1 times 5 is going to be -5. And the other one's going to say x minus 5. So we left with, now we can cancel something out. We can cancel out x minus 5 over x minus 5. And we left with 1 on top over -x minus 5. Number 4 says x over x squared minus 49 minus 7 over x squared minus 49. So you have x minus 7 over x squared minus 49. We could separate that bottom and make it say it's the difference of two perfect squares, x plus 7. This one's a little bit easier than the last one. X minus 7. And we have something we could cancel out right there. We could see what's on both the top and the bottom, x minus 7. So 1 over x plus 7. Number 5 says simplifying. So now just going back, just taking out what they got in common. 2 comes out of the top times x minus 5 gives you 2x minus 10. 2 comes out of the bottom as well times x plus 2. What they have in common on the top and the bottom is 2. X minus 5 over x plus 2. You have 5x to the 5th on top. At the bottom, they both have x to the 5th in common. So x to the 5th times 1 is x to the 5th. And x to the 5th times -3x, because you have to add one more x to it. So now see what they got on both in common on both the top and the bottom. X to the 5th can cancel out. So 5 over 1 minus 3x. Number 7, factor out what's on top. You have two sets of parentheses, x times x. The only factors of 5 are 1 and 5. Then you just have to determine which signs you're going to put in front of them. This one tells you the opposite. This one tells you the larger sign. 5 is positive. This one's going to be negative. Okay, here's another example, like earlier, where you multiply by -1. So you have x plus 5 times x minus 1. And you have 1 minus x on the bottom. When you multiply it by -1 over -1, now let's go past this one real quick. There's not enough explanation for tomorrow's test. Let's go to number 8. Just cross it out. All right, so if we break these two down into binomials, x times x, you have to pick your factors of 24. 1 and 24, 2 and 12, none of them get you to 2. 6 and 4 are the only ones that get you to 2. So you have to use 6 and 4 to get to 24. It's an opposite sign. This one tells you the opposite one says that the larger number's negative. So -6, +4. You have x times x at the bottom. 36, 7, or 9 and, no. Your factors of 36 are 1 and 36, 2 and 18. 3 and 12, and 9 and 4. 9 and 4 are the ones you're going to want to use. That gets you to 5, 9 and 4. And 6 and 6 doesn't get you to 5. This tells you the opposite signs. This tells you the sign of the larger number. So -9, +4. And you can see what you can cancel out now. +4 over +4. X minus 6 over x minus 9. Two trinomials again, x times x, x times x. Factors of 15, 1 and 15, and 3 and 5. The only one that gets you to 2 is 3 and 5. This one tells you the signs are opposite. This one tells you the sign of the larger one. So negative, positive, just like that. Over, again, x times x. Factors of 10, that'll get you to 7. You got 5 and 2, or 1 and 10 and 5 and 2 are the only ones. 5 and 2 are the only ones that get you to 7. So you have This one tells you they both the same sign. This one tells you they both negative. So -5, -7. You can see what you cancel out, x minus 5. So x plus 3 over x minus 7. X minus 2 here, not x minus 7. I wrote a 7 there. Still, x minus 5 is the one that cancels out. So you have x plus 3 over x minus 2 for number 9. Number 10, you multiply straight across. 4 times 3 is 12. 5 times 2 is 10. 8 times 8 to the second becomes 8 to the third. What do they have in common? The number 2 goes into both of them. It goes into 12 6 times. It goes into 10 5 times, and you have 8 to the third. That's all you can do to simplify it. Next one says q minus 4 over 3 times 4q over q minus 3. So what you have is 4q times q minus 4. If you write it this way, it's easier to see. Over 3 times q minus 3. Remember, the order of multiplication is not going to change anything. To see what we can cancel out. When you multiply 4 times q, like sometimes you have to go backwards and forwards with it. 4 times q is 4q squared minus 16. Over when you distribute this one, you have 3q minus 9. Okay, once you see that, you can see at the top, you have the difference of two perfect squares. So you have the difference of the square root of 4 is 2, q plus 4, times 2q, save space, 2q plus 4, times 2q minus 4, over 3q minus 9. That's all you can do with that. We kind of made it longer. That's all you can do with it. There's nothing else you can reduce. You have the difference of two perfect squares to start number 12. So you have x squared minus 16. So x plus 4 times x minus 4 at the top over 6x times 7x over x plus 4. Again, you don't have to multiply it before you cancel out. Anytime that you have the same thing, you can cancel it out. So you have 7x times x minus 4. You can see it a little bit easier if you write out this step. It's not a necessary step to write out, though, because you can see that they both have x in them, so you can cancel out x. So 7 times x minus 4 over 6. So you have k plus 3 over 4k minus 2. You can take out the number 3, so times 4k squared minus 1. So that created the difference of two perfect squares right there. 4k squared minus 1, when you separate it, is 2k plus 1 times 2k minus 1. So that's times 3 still over 1. You still have k plus 3 here. You can take out the bottom of 4k minus 2. You can take 2 out, and it gives you 2k minus 1. So you can see what you can cancel out there. 2k minus 1 over 2k minus 1. So when you reorder everything, 3 times 2k plus 1 times k plus 3 over 2.